Welcome to Lesson 18. In Lesson 18, we'll investigate fractional and negative powers. We'll find out what a negative power is and how we use it, what a fractional power is and how we use it, and then, of course, we'll combine that and look at negative fractional powers. What is a negative power? To understand a negative power, we have to use what we've learned before about working with numbers in exponential form. Here's a simple division problem. 6 to the 4th divided by 6 to the 7th. What do? Well, dividing numbers with the same base, we keep the base and subtract the powers. 4 minus 7 is negative 3. So we have 6 to the negative 3. If we go back and look at this problem and see what it means, then we'll understand what the negative 3 power is. We have 6 times 6 times 6 times 6 in the numerator, and we have 7 6's multiplied, that is 6 to the 7th power, in the denominator. We can cancel by dividing by 4 of the 6's on top and bottom, leaving a 1 in the numerator and 6 to the 3rd in the denominator. Therefore, 6 to the negative 3 equals 1 over 6 to the 3rd. What is that called? What do we call a number which is 1 over another number? I believe we call that a reciprocal. In fact, we can double check. Remember, a reciprocal is a number which, when multiplied by the original number, we get 1. 6 to the negative 3 times 6 to the positive 3, we keep the base and add the powers. Negative 3 plus positive 3 is 0, and of course 6 to the 0 is 1. So indeed, 6 to the negative 3 is the reciprocal of 6 to the 3rd, 1 over 6 to the 3rd. In general, we can say if we have a base b raised to a power negative a, that b to the negative a means 1 over b to the a. Now, how can we use this? Well, let's recall back our dividing of fractions. If we divided 2/3 by 4/5, we said dividing by 4/5 was the same as multiplying by its reciprocal, that is, multiplying by 5/4. So notice, as you can see on the screen, that dividing by 4 to the 4th would be the same as multiplying by its reciprocal being 4 to the negative 4th. So 4 to the 3rd divided by 4 to the 4th is identical to 4 to the 3rd times 4 to the negative 4th. Similarly, 7 to the 11 divided by 7 to the negative 3 is the same as 7 to the 11 multiplied by the reciprocal of 7 to the negative 3, which is 7 to the positive 3. Okay, let's take a look at a problem and see how we apply this knowledge of the negative power being a reciprocal to an order of operations type problem. Here we have a number of multiplications and divisions of numbers all with the same base, 4, all raised to different powers. What are we going to do? Well, just as we said, we're never going to subtract integers, and we always said, okay, instead of subtracting integers, we added the opposite. We are never going to divide numbers in exponential form. As long as the bases are the same, we'll simply change the sign of the power. That is, take the reciprocal of that number and multiply instead of dividing. So you'll notice on the second line, we've taken dividing by 4 to the negative 3, and made it into multiplication by 4 to the positive 3. We've taken dividing by 4 to the 2 and changed it into multiplying by 4 to the negative 2. Dividing by a base to a power is the same as multiplying by that reciprocal, the reciprocal being the same base with the power of opposite sign. And now we have strictly a multiplication problem, all with the same base. We keep the base and add the powers. 5 plus 3 is 8. 8 plus a negative 7 is 1. 1 plus a negative 2 is negative 1. So our answer is 4 to the negative 1, which of course is 1/4. I hope you understood that process. Now let's go to the whiteboard and look at another problem. Here's a problem. 8 to the negative 5 divided by 8 to the negative 6 times 8 to the 4 divided by 8 to the 2nd times 8 to the negative 3. Write that problem down, stop the tape, and work the problem and come back when you have an answer. Okay, how would we do this problem? Well, very simple rule. We're going to say we're never going to divide numbers in exponential form if all the bases are the same. Well, all the bases here are 8. So we're going to take each of the division problems and change them to multiplication problems. 8 to the negative 5 doesn't change, but dividing by 8 to the negative 6 is the same as multiplying by 8 to the positive 6. We're not going to change multiplication, so we'll leave that alone. Dividing by 8 to the second is the same as multiplying by 8 to the negative second. And of course, multiplying by 8 to the negative 3 will not change. Well, now we have a bunch of multiplications, all of which have the same base. To solve this, all we have to do is keep the base, 8, and add the powers. Negative 5 plus 6 is positive 1. Positive 1 plus 4 is positive 5. Positive 5 plus negative 2 is 3. And a 3 and a negative 3 is 0. So our answer is 8 to the 0, which of course we know is 1. So it's rather interesting that this fairly complicated problem has a very simple answer, 1. You'll also notice I said positive at times and didn't put positive symbols. And we said earlier that as for our consideration, positive 6 and 6 are identical. Only a mathematician would probably care about the difference, that positive 6 was an integer and 6 was a counting number. All right, now we maybe have a pretty good feel for negative powers and their uses. What we need to do now is take a look at fractional powers. What does a fractional power stand for? Well, here's an example. We see we have 5 to the 1/3 times 5 to the 1/3 times 5 to the 1/3. And of course, we know that it's equal to 5 to the 1. How do we know that? Because the base is the same. We keep the base and add the powers. And 1/3 plus 1/3 plus 1/3 is 1. Now we know that 5 to the 1 is 5. So 5 to the 1/3 times 5 to the 1/3 times 5 to the 1/3 is 5. I would like you to stop the tape and think about what 5 to the 1/3 means. Think about it. Come on back to the tape, whether you get an answer or not, and then I will try to tell you and show you if you have the right idea as to what 5 to the 1/3 means. Please do that now. Well, as you can see, 5 to the 1/3 times itself means 5 to the 1/3 cubed equals 5. So 5 to the 1/3 is a number which when cubed gives us 5. By definition, that is the cube root of 5. Notice we have the same radical sign that we use for square root, but now there's a 3 in the front of that symbol. That's the third root or cube root. If there was a 4 there, that would be the 4th root. If there was an 8, it would be the 8th root, etc. Okay? Now what I'd like you to do is look at 9 to the 1/2 power. Stop the tape and decide what is the value of 9 to the 1/2 power. Well, 9 to the 1/2 power is not 4½ It is not half of 9. The 1/2 power is the square root. And the square root of 9, of course, is 3. So we now can see that if we have a power, 1/5 power, it would be the 5th root. The 1/8 power would be the 8th root. But what would the 2/3 power be? Well, here's an example that might lead you to recognition of what the 2/3 power means. 7 to the 2/3 times 7 to the 2/3 times 7 to the 2/3 is equal to 7 to the 2nd power. Because 2/3 plus 2/3 plus 2/3 equals 2. I'd like you to stop the tape and decide what the 2/3 power means. Well, what we did is by taking 7 to the 2/3 and multiplying it by itself and then by itself again, we actually cubed 7 to the 2/3. That is, 7 to the 2/3 cubed is 7 squared, which means we have a cube root of 7 squared. That is, 7 to the 2/3 is the cube root of 7 squared, or we could write it as the cube root of 7, and then we square it. In any case, what it appears to mean is that the numerator is the power, and the denominator is the root when we have a fractional power. So here's an opportunity for you to see if you understand this. 25 to the 3/2 power. What I'd like you to do is tell me what that means. Well, the 3/2 power is the square root cubed, or we can take the square root of the cube. Which would you rather do first? Take the square root of 25 and cube it, or would you rather take 25 and cube it and then get the square root of whatever 25 cubed is? The answer would be the same, but it's generally a lot easier to take the square root first, or whatever root is, and then raise it to the power. So let's take the square root of 25 and then cube it. Well, the square root of 25 is 5, and 5 cubed is 125. So 25 to the 3/2 is 125. Here's another problem. 64 to the negative 2/3. Now wait a second. That's a negative fractional power. Why don't you go back and think about what a negative power means, think about what a fractional power means, and think about what 64 to the negative 2/3 power means. Do whatever it means and get a numerical answer. So stop the tape and examine 64 to the negative 2/3. The negative says take the reciprocal. The 2/3 power says we're going to raise it to the second power and take the cube root. So the first thing we're going to do is take the reciprocal. 64 to the negative 2/3 is 1 over 64 to the 2/3. But 64 to the 2/3 is the cube root of 64, and then we square it. The 2 in the numerator, the 3 in the denominator of the fractional power. 1 over the cube root of 64 squared. Well, as you can see, the cube root of 64 is 4, because 4 cubed is 64, and 4 squared is 16. So the answer is 1/16. Okay? So we can see that the negative fractional power is simply the reciprocal, and then we apply our knowledge of fractional powers, the numerator being the power, the denominator being the root. Now, the question comes about, can we take powers of negative numbers? And the next example would help us decide whether we can do that or not, or how we do it. We see we have negative 5 to the second. We also have a negative 5 in parentheses to the second. Is that the same thing? When we have parentheses, generally there's a reason for it. Let's see. Negative 5 to the second. What do we do first? Do we raise it to the second power, or do we put the negative in front of it? I believe that since we consider the negative as if we were multiplying by a negative, we would raise to a power. We use the exponent before we multiply. So that would simply be negative 25. The negative does not affect the power. But if the negative is in the parentheses with the 5, we always do what's in the parentheses first. That means take the negative of 5 and then square it. Well, squaring means multiplying it by itself, and negative 5 times negative 5 is a positive 25. So it does make a difference. If you're going to square a number and include the negative, that negative has got to be in the parentheses, and then you square it. Well, notice when we squared it, we got a positive number. When we raise a negative number to a power, do we always get a positive number? Let's take a look at 2 examples. Here's negative 7 to the 6th and negative 8 to the 5th. The base is not important, except that we know it's negative. It's the power that's important. Notice when we raise negative 7 to the 6th power, we have 6 negative 7s multiplied. We can pair those negative 7s up, and you notice we have little marks to indicate that each 2 of them are paired up. And each pair of those is a positive number. since negative 7 times negative 7 is positive 49. And a positive times a positive times a positive is positive. So when we can pair up all the negative bases, we wind up with a positive number. Negative 8 to the 5th, notice we cannot pair up all the negative 8s. And the reason is we have 5 of them. We can pair up 4 of them, and of course negative 8 times negative 8 is 64, and 64 times 64 is going to be a large positive number. When we multiply that large positive number by the last negative 8, we are going to get a negative number. So what we've discovered here, it seems, is that if you raise a negative number to an even power, the answer is positive. You raise a negative number to an odd power, the answer is negative. The question now is, what kind of power would we have to raise a positive number to get a negative answer? And I'd like you to stop the tape and think about that. Think about raising a positive number, such as 2, to a power and getting a negative answer, perhaps negative 4. Stop the tape now, think about that, and come on back when you are done. The question is, 2 to what power is negative 4? Well, you know that a negative times a negative is a positive. But I cannot multiply a positive times a positive and get a negative. So there's no way to raise positive 2 to a power and get any negative number. I don't care whether you use a negative power, a fractional power, any kind of power, you will never get a negative number. The only way to get a negative number by raising a number to a power is if the original base is negative and the power is odd. Otherwise, you cannot do it. You cannot raise a positive number to a power of any type and get a negative. Okay? Here's another problem for you to consider. Negative 27, in parentheses, raised to the negative 4/3 power. Okay? I want you to stop the tape and step by step work this problem out so that you get a final answer, which is a number. You should be able to get a number for this problem. Do that now, please. Okay, negative 27 to the negative 4/3 power. Anytime we have a negative fractional power, we take care of the negative first. The negative power means take the reciprocal. So negative 27, in parentheses, to the negative 4/3 power is 1 over negative 27, in parentheses, to the 4/3 power. What does the 4/3 power mean? Well, it's a fractional power. The numerator is the power. The denominator is the root. So we're going to have 1 over the cube root of negative 27, and then we're going to raise that answer to the 4th power. What is the cube root of negative 27? What number raised to the 3rd power will give us negative 27? Well, let's break that down into 2 parts. What number raised to a power will give us 27? Well, 3 raised to the 3rd power will give us 27. Now the question is, how are we going to get negative 27? Well, it would appear that a negative to an odd power, and certainly 3 is an odd power, will give us a negative number. So the cube root of negative 27 is negative 3. So now we have 1 over negative 3, and notice the negative 3 is still in parentheses because we're working with the negative 3. We have 1 over negative 3 to the 4th. Well, what does negative 3 to the 4th mean? Well, a negative to an even power is positive. And 3 to the 4th means 3 times 3 times 3 times 3. So the answer is positive 81. So negative 27 in parentheses taken to the negative 4/3 power turns out to be 1 over 81. A relatively small fraction, but a lot simpler to look at than negative 27 in parentheses to the negative 4/3 power. By the way, what would have happened if no parentheses had been there? We would have taken 27 to the negative 4/3 power, and gotten 1 over 81, the same as we got here, and then put a negative. So if that parentheses wasn't there, the answer would have been negative 1 over 81. So using the parentheses here is critical in getting the right answer. Okay. And the fact is, just looking at this problem, let's go back and look again at what we just did. We had negative 27 to the negative 4/3 power. How could we know by just looking at that the answer would be positive? Well, you might say we know we can take the cube root of a negative number because we see the 3 in the denominator. The fact that it's a negative power simply means the reciprocal. We're going to take the cube root. And when we take the cube root of a negative, we're going to get a negative number. And then we're going to raise it to the 4th power because the 4 is in the numerator of the fractional power. And a negative to an even power will be positive. So just looking at this problem as it stands with the parentheses, we should be able to recognize that our answer must be positive. That's important to note because sometimes when you're doing a multi-step problem, if you lose track of where you should be going, you might wind up with an answer, think it's correct, and in fact it would not be because there was an error in sign. It's sort of an estimation kind of skill, looking at a problem and saying, should this be positive or should this be negative? Okay? Let's take a look at negative 8 to the negative 5/3. Negative 8 to the negative 5/3. Okay? What kind of answer will that be? Well, let's see what that means. Negative 8 to the negative 5/3. Notice the negative 8 is in parentheses. We are going to take the reciprocal of negative 8 to the negative to the 5/3. 1 over negative 8 to the 5/3. The negative power is the reciprocal. What does negative 8 to the 5/3 mean? Negative 8 to the 5/3 says we're going to take negative 8, take its cube root, and then we're going to raise that to a 5th power. What is the cube root of negative 8? Well, the cube root of negative 8 is that number which when multiplied by itself, that is, that number when cubed, gives us negative 8. It's going to have to be negative, because we can't get a negative by cubing a positive number. And it's going to be 2, because 2 cubed is 8. So we know that the cube root of negative 8 is 2, actually negative 2. And we want negative 2 to the 5th. Notice that negative 2 would be in parentheses. We have not replaced the parentheses until we raise it to that 5th power. And negative 2 to the 5th power is a negative number, the 5th power being an odd number. And 2 to the 5th is 32, so therefore negative 2 to the 5th is negative 32. And rather than writing it as 1 over negative 32, our final answer is negative 1/32. Negative 1 over 32. Okay? And of course, that was a negative number. By just looking at the original problem, we have a negative base. We're going to take a cube root of it, which means we're going to have a negative answer. And then we're going to raise that to an odd power. Thus, the final answer will be and is negative. Okay, I'd like you to do this one problem on your own, 4/9 to the negative 3/2. This is a little different because we have a fractional base and a negative fractional power. So what I'd like you to do is go ahead and stop the tape and work this problem out using what you know about negative and fractional powers. Okay, we have 4/9 to the negative 3/2. We have a negative power. We always take care of the negative first. Well, the negative power means the reciprocal. What is the reciprocal of 4/9? Well, if you said 1 over 4/9, that's too complex. The reciprocal of a fraction, we just simply exchange the numerator and denominator. The reciprocal of 4/9 is 9/4. So we have 9/4 to the 3/2. The 3/2 says take the square root. Well, take the square root of 9/4. We can do that very simply by taking the square root of 9 over the square root of 4. And then raise those numbers to the 3rd power, as you see. The square root of 9 is 3. 3 to the 3rd is 27. The square root of 4 is 2. 2 to the 3rd is 8. So we have 27/8. Of course, what should we do with 27/8 as an answer? Thinking back to our investigation of fractions, we should simplify this. And of course, 27 divided by 8 is 3, with a remainder of 3, so this will be 3 3/8. But in many cases, when you're doing problems involving powers and roots, if a fraction is involved, the answer is left as a fraction. So certainly 27/8 would be a good answer for this type of problem, but 3 3/8 would be a good answer for this series of tapes because we hope that you remember how to work with fractions. We've got time for one or two problems. Let me clear the whiteboard here and look at a problem. Here's an interesting problem. 64 to the 1/2 times 64 to the 1/3. Work that problem. I'm going to show you how to work it in two different ways. Work that problem at least in one different way, and come on back, turn the tape back on again when you have your answer. Well, the first way to work this, of course, is to recognize that the 1/2 power is the square root. And the square root of 64, we can find that out. And the 1/3 power is the cube root. The cube root of 64, we can find that out. So we can simply go ahead and do this. Let's see what we get. We get the square root of 64 is 8. The cube root of 64 is 4. And we get 32 is our answer. Now, that's one way to do it. Is it the only way? No, it is not. We'll go ahead and erase this and go back and look at that problem as a multiplication problem. We multiply two numbers in exponential form. They have the same base. What do? We keep the base and add the powers. Well, now we're back to adding fractions. As I've said many times throughout this tape series, we'll need to call upon things we learned in previous lessons. 1/2 plus 1/3. Common denominator is 6. 3/6 plus 2/6 equals 5/6. So we have 64 to the 5/6 power. What does that mean? Well, that means we take the sixth root of 64, and then raise that answer to the 5th power. The 6th root of 64 may seem kind of complex, but it really isn't. Because 64 is such a small number that when I take the 6th root of it, the answer's got to be fairly small. In fact, the answer is 2, because 2 to the 6th is 64. And now we're stuck with 2 to the 5th power. What is 2 to the 5th power? It's 32. So in both methods, we got the same answer. Probably the first method is easier because we're able to take the square root of 64, the cube root of 64. We got two nice numbers, 8 and 4, and we multiplied them. But here we had to use our understanding of multiplication of numbers in exponential form and recall our ability to add fractions. Okay, so we've seen a number of new things in this lesson. We have seen fractional powers, where the numerator is a power and the denominator is a root. We've seen negative powers, where we have reciprocals. That is, 3 to the negative 2 power is 1 over 3 to the 2nd, or 1/9. We've seen negative fractional powers, which combines those two. It's the reciprocal, and then we take the power, the numerator being the power, the denominator being the root. We've also looked at the powers and roots of negative numbers. And we can take the odd roots of negative numbers because when we take a negative number and raise it to an odd power, we get a negative answer. We take a negative number and raise it to an even power, we get a positive answer. So we've taken a look at various ways of using powers and roots. And hopefully you've understood that. So this sort of concludes our look at arithmetic. And next we'll be delving into the world of geometry. In Lesson 19, we'll meet in Geometry Part 1.